Now, I'm very excited to be here because two of the company produce medical robotic technology that I will eventually use in the next 10 years. So I just want to know my suppliers. Alan from NDR is something very interesting. It's a precision needle placement device that helps hospital and medical practitioner to insert needle and to do automatic lesion targeting, correct?
Roger, I'm just going to butt in. Sorry guys, I just need to let you know we're doing audience Q&As, so we're using Slido, so please go to slido.com and put in the conference code and you can find Arise on there and you can get your questions in for the end of the panel.
Yeah. So NDR Medical does precision medical targeting, and it's a very interesting technology. Also, Tristan is from H3 Dynamic. They provide brain to fleet of autonomous aerial drone for some very interesting application. And lastly, Colin Endomaster puts a robotic arm into your stomach and extract large masses of growth. So if those three companies ever merge together, run, because there'll be a flying robot that can remove stuff from your body. So I'd like to see if there are any robotic startup in the audience. Anybody doing hardware, robotics? Okay, there's a few. Hopefully we can get some interesting question for you guys. So Alan, tell me more about a use case where you guys use robotic.
Oh, sorry. I literally want to take the mic away from you. No, it's okay, it's okay. We will share the mic.
Not the first time happened to me at karaoke.
Okay. A very good use case is that because, like what was mentioned, that we actually do biopsy and ablation. The use case for robotics is very simple. It's just a more precise tool that actually can be more productive for the doctors. But the social impact behind what we are developing, I think that's the cost that actually we want to focus on. Regardless of what robotics is used in, so long as the social cost of it, the medical benefit that's going to be derived for using that particular equipment, device, as you would say, the technology behind the AI-driven deep learning, machine learning, the use case ultimately is to improve the clinical outcome, whether a patient can be treated at a much earlier stage or in a more precise, more beneficial, at a lower, more affordable cost. And the robotics that we actually developed, what we are trying to do is really to bring down the cost of surgery so that per surgery cost is actually quite affordable. And for what we have developed, we have checked with the market. After about 70 plus procedures, we can actually cover the cost of it. So I would encourage anyone who is developing robotics, try to bring down the cost, have a great social impact.
Hey, thank you. Tristan, tell me about H3 Dynamics.
Okay, you see me? All right, H3 is a pretty broad organization. We're a startup, we're Singaporean, but we actually, we operate in three very different but very complementary fields. The first is we build hydrogen fuel cells. These fuel cells are typically utilized in fixed-wing aircraft because they're very light. The second part of our business is around robotics, where we build autonomous launch stations for drones. And the final piece is around artificial intelligence and software platforms. Now, for the purpose of today's discussion, I'll probably focus more on the second two. Ultimately, what we look to do is we utilize drones as autonomous or semi-autonomous data collection devices. Drones are kind of like a sexy thing at the moment, but realistically all they are is just a flying camera or what other sensor you want to sort of bolt onto them. So with the technology stacks that we've developed, we actually find some very, very broad use cases. I can go into more detail on one if you want or later.
What can you got? Colin, Endomaster?
Sure. You can just give an introduction.
What you guys do a use case for?
Yeah, so just the quick version of what we do is we basically utilize robotics in your gastrointestinal tract. So it can be anything from your throat to your stomach to your large intestine. It's not a very fun topic to talk about, but 1/5 of all cancers in the world actually do occur in your gastrointestinal tract because of what we eat, because of genetics and our environment. So we use robotics to actually put two little robotic arms into the body, into your throat, or up from behind through the anus to actually remove cancers from your GI tract. And the use case is very, very applicable because right now, if you do have that situation, you're going to have to go for surgery. And surgery, most doctors won't tell you this, but actually surgery is really controlled trauma. You're basically cutting open your body to fix the patient. So we want to get rid of all of that. We want to put a flexible robotic system through the mouth into your body and remove it and take it out. And we've done it on some patients and we've gone home the same day. And the idea is basically to change the way that surgery is currently done. So to us, that's actually the value of what robotics brings. I know Alan mentioned that robotics is a very sexy word, but at the end of the day, it's really about the value that you bring to your customers. In our case, it's the patients and the doctors.
Thank you. Go to Endomaster's website. There's really good video about what the machine does. Just don't do it after meals, please. Okay. One of the things interests me in robotics is that how you affect the workforce. Like when magnetic resonance imaging was introduced into hospital, the equipment and the medical imaging technician needed to interpret the data altered most hospitals' power dynamic, and because the doctor and the technician have to communicate, the diagnostic became better. Now, talk about how your technology is changing the workforce or the behavior practice at your client's site. Because I know for H3 Dynamic, they actually changed significantly the inspection process of their client's site, which will be interesting. So can you tell me how you see that altering the medical practice or the organization culture?
Sure. Shall I go first? Okay, I go first. In terms of what I see, first and foremost, unfortunately, because we are developing surgical robotics, and our targeted user or our customer, someone is going to pay us, happens to be the doctor, happens to be the user that we're actually selling to. So I won't say that we are going to replace them, but we are going to be an assistive tool so that they can do their job at a much better, at a much productive manner, so that, in a sense, it's more precision, better clinical outcome. They can do more cases, just like what you previously mentioned, so long as the diagnostics, they get more precise in that manner. So what we are trying to do here, we are not replacing anyone. We are really making those hospitals with manpower shortages with some assistance that they can do.
Ellen, you mentioned something about the product making junior physician more effective and lower their learning curve. Talk about more about how a machine teach a physician to become better at surgery, please.
Yep. Generally for what I do is, I'm doing a needle biopsy or needle ablation. Generally for surgeons to be equipped or to be expert in this area, he has to be puncturing more than about 150 times before he can do the puncture himself. If not, he has to be guided. But with a robotic system like ours, the learning curve of it, we try to make it very smart using AI technology. So right now, most of the residents, most of the junior doctors who have seen, who have used our equipment, literally just get a hang of it. Instead of going through the long learning curve, if we are talking about Da Vinci robotic system, it takes about 6 months to actually train one single surgeon to be proficient in that particular surgery that they're performing. But with our system, we realize that just by 1 hour training, we tell you which button to press, literally they can become an expert in that field as well. So I don't think so in Singapore, we are able to get all the junior surgeons to be puncturing above 150 times. So generally, you have a good understanding of how the procedure is being performed. Using our robotic system, we can rest assure you, you will be as good as surgeons who have punctured more than 150 times. In that aspect, I think we actually shift or we rise the clinical or the medical standards within all hospitals. So right now, all hospital should be a good hospital.
Thank you. Remember, when Alan says puncture, there's somebody being punctured, and it could be us teaching a junior surgeon, or it could be us having an expert surgeon puncturing your organ. So the benefit is huge, at least for me, who will be needing this procedure in the future. Tristan?
Nice. Okay, look, Alan, you raised a great point. One of the constant narratives I hear when I go and speak to customers and users of robotics and artificial intelligence is there is this underlying fear of being replaced. They're going to take our jobs, we're going to disappear, what are we going to do? What we look to do is to find And one of the reasons we work across a number of industries is because we look to find really core problem statements for dangerous, difficult, expensive challenges that exist in the world. And what we look to do is to be able to supplement and add value to the people doing these jobs so they can do it in a more efficient, they can do it in a safer, they can do it in a more cost-effective way, or even just collect better results. One project that we have running in the US at the moment is with one of the major energy providers. These guys are a gas company. And the current process for people to go and find leaking gas was literally walking around in a field holding a sensor, which is super unsafe, very laborious, going to take a long time, and difficult. And what we sort of did is we looked at our technology stacks and went, okay, if we can pre-plan and intelligently plot a drone to fly around this area with a special laser gas sensor attached to it, and then we coupled that data with weather data and work out what the wind's doing and a bunch of other stuff, we can really derive with a fairly high degree of accuracy where the leaks are coming from. Now, this is a problem that is in the billions in the US alone. If you look globally, it's $30 plus billion a year. And as I said, on top of it being a financial challenge, it's also incredibly unsafe, and it's actually difficult to get people to go and do it. So what we really look to do is to change some workflows by empowering the people doing the jobs to do it in a safer and more effective way.
Well, that's a job that nobody should have. Like, you're literally walking through an explosive area with a sensor trying to detect leak. That's a job nobody should want to do. So let me ask this. Does the company do more inspection because it's autonomous, it's cheaper and safer, or they just do the same number of inspection?
Say that again.
Does the company do more inspection with your drone controlling technology because it's cheaper, safer, it can be done any time of day?
Yeah. So look, we do all sorts of inspection. Our core product, which I won't really talk about today, is around the inspection of buildings. One of the reasons we're based out of Singapore is we've been lucky enough to be supported by some of the major government agencies here that manage and build property. For example, JTC is one of our core development partners for this autonomous inspection software. And we're actually going to be launching it globally at the World City Summit in early July. So if any of you guys are around, free plug.
Thank you. Colin?
Well, I guess for us, the workflow changes because instead of, like I was saying just now, instead of doing surgery, you're basically having a much less invasive platform. Like I was saying, we use endoscope technology, put it down the mouth, take it out of the stomach, and then you're done. So the workflow actually dramatically changes. We actually change the way that surgery is being done, as cheesy as that sounds, but literally you are removing the whole surgical procedure, which means a much shorter time. We can do it in about half an hour versus a surgery that can take 4 to 6 hours. The complication rate's a lot lower. You're going to stay in the hospital a lot less because, as you can imagine, you're not cutting open your body anymore. If you do a surgery, you'll be staying for minimum 4 days, if not a week and a half if something's complicated. For us, we've seen patients go home the same day. And on top of that, actually, the whole, on top of workflow, I mean, to me, what's more important is actually the patient. I mean, eventually, you know, it's a knock on wood situation, but all of us is going to go for some sort of medical attention when we're a lot older. And you just don't want to be in a situation where you're going to have to change your diet, change your lifestyle, change your psychology. I mean, when I meet a lot of cancer patients, a lot of it comes down to, especially gastrointestinal patients, you actually deal with changing your entire diet. Some of them have to walk around with what they call like a stoma bag because, you know, basically they can't pass motion the natural ways anymore. They come through a bag. You have to change your whole way you're living. And the psychology is hugely affected because you've basically done a huge operation and you just never know whether that cancer is going to come back. So to me, that's actually the bigger impact that we create. With the workflow in the hospitals is great, but also with just the lifestyle of the patient. It completely changes.
So how autonomous is the surgical arm, or is just a control by the surgeon?
Yeah, I'm sure some of you have heard about how, you know, when you talk about autonomy with robotics, you have these 5 stages, stage 5 being the AI automatic version and stage 1 just being simple assistive version. So we're literally at stage 1 because our goal is really just to help give the surgeon a better tool. We can look into going to stage 2 and 3 where you have some level of autonomy, but in Endomaster's case, I doubt we will get to this automatic robot where it's just going to work on you straight away anytime soon. only because of the data. I know there's some questions here about AI and stuff, but if you talk about new robotic procedures, you're going to need a lot of data. So right now I have zero data, right? I can't go on YouTube and Google whoever else is doing these type of procedures. We're basically going to be the first in the world. So it's a different problem for us. I know it may be different for you guys, but for us it's different.
Sure. I know that HT Dynamic use quite a bit of AI, and I think you guys also use AI for learning. Now, my question is, as robotics become more autonomous through learning, through AI, we get into this gray area where they're making a fairly large number of decisions that may have real-world consequences. Take Tesla hitting pedestrians. At what point do you step back saying, okay, this is the limit of our liability. Beyond this, we cannot be responsible. Where do we draw the line where this is our product to the point where this is not our responsibility? Because you're going to get these kind of weird boundary issues the more you deploy deeper into an organization.
Maybe I'll just share quickly on that. Look, honestly, I don't have an answer to your question. I don't think anyone can conclusively answer that. I see someone's written something about Skynet down there, and that's ultimately where we're going, right? But look, the reality is even in the simplistic AI and machine learning chatbots and things that exist today, there is capacity for this stuff to go wrong. I can't remember exactly which company it was, but I remember reading relatively recently that someone had deployed a chatbot. And we're talking like major tech company here. And then some people that were pretty savvy around machine learning got in there and started feeding it certain statements, and it became fairly anti-Semitic about...
Never speak back of your previous company, Tristan.
Was that who it was? Anyway, but my point is that, look, this is a very exciting technology. It's going to fundamentally change the world in ways that, in a time period that is much shorter than anything that's gone before it. And even as an example as simple as that shows that it can go very wrong very fast.
Yeah.
Go ahead. I fully agree with what you mentioned, because right now I think we are still pretty far away from the days of the Skynet, at least 10 or 15 years later. But at this stage, what we are trying to see is that autonomous, being AI-driven, the application is determined by us, the programmers, the developers. So what we foresee at this near term, 5 years, is to develop something autonomous so that surgeons, so that humans could have a better living, have a better life, better outcome. Given that whether there will be one day whereby our surgery is done fully automatic, I think that might be a possibility. But of course, as developers, there will become a time we have to have that moral decision whether we want to automate the entire thing, whether a human is still required in the entire process, or we do allow the whole autonomy to just go ahead. Also, depending on which application you are targeting. In terms of surgery, if let's say today, robots can do far better surgery than a human can do, probably we are more targeted toward that area. But unfortunately, in the medical field, I think because of regulatory hurdles, humans, doctors, surgeons are still very much required. But of course, in terms of, not my expert area, but in terms of autonomous vehicle, in terms of drones, that could be more immediate application. But if we are going to develop like a machine, like a tank, automated tank that's going to invade, so let's not go into that area. But like what I mentioned here, the AI or the autonomous vehicle device that we are developing, the application is crucial. What we are actually targeting to do, some part of it I want to push AI and autonomy as fast as possible. Some part, probably in the medical field, I will try to slow down the pace so that probably AI could literally reach a stage whereby it will surpass human intelligence.
So on this, I have a question for you. So NDR does precision targeting a needle insertion to make sure you hit the right area. Is there a possibility to develop a targeting technology to minimize pain? This is where we talk about robot and humanity. In a robotic system, we want a precision injection of needle. But from a humanity point, maybe we want the least painful injection method, and those may not be compatible. Sorry,
No,
put you on the spot.
no, you didn't put me as spot. I mean, I've been speaking to doctors for the last 5 years. I shouldn't be saying this but we have seen some clinical application, the way things are being done, epidural. Sometimes it's a hit and miss thing. Even in terms of pregnancy, when you give epidural when they are due, sometimes when you do it inaccurately, you only numb half of the body, so the other half you still feel the pain somewhat or another. So having a more precise tool or a device that we mentioned here, we can actually, with AI, we actually can advise doctors in terms of the data that we can generate, where is the best puncture site, how deep you should go, how fast, how long you should keep the needle within the body. These are some of the data that we can actually already collect. And with that, I literally believe with a single puncture, with precise technology, pain management is very much controlled. Instead of, just give an account. Right now, even when we talk about minimum invasive surgery, even though we don't cut you open, but when multiple puncture was being performed, internal hemorrhage, where you puncture other organs, is a real thing. It's a real thing that's going on. So with AI, we are trying to make it more precise so that all this accident doesn't happen within the body. So some traditional saying that in the past, when we do open surgery, the surgeons literally see everything. It's open. But when you do minimally invasive, there's another risk because you don't actually see it, and you view internally through some medical imaging like CT or fluoro. And that aspect, it creates another level of difficulty for doctors to visualize in three-dimensional space. And what we develop is that with AI, with image analysis, surgeons can be relieved of the headache, of the stress that they have to visualize in 3D because the robot is doing the entire complexity in terms of the targeting. So surgeons only have to do the final puncture, and we have done more than 20 animal trials. So far, it has always been one single hit to the target. But conventionally, it's done in research that minimally they have to do about 2 to 3 punctures. And worst scenario, we have seen up to 8 punctures just to get it right in place. So it's a painful process. With AI, with robotics, trust us. So if let's say there's any investors out there, we are really doing a good job, so do invest in us. Because we do definitely, why we are in this as well? Because we really do see in the future, we might be the user of our own technology.
I know I will be. Yeah. Thank you, Colin.
I think you guys have answered most of the points, but I think what's probably going to happen is just the big R word, right? It's going to be regulation. There has to be some level of regulation. I think especially in the medical field, Alan and I know it best, where when it comes to medical devices, it's a very regulated industry. Maybe initially for us now, when we're in this stage 1, where it's just robotic assisted, you don't have any AI, I would still say it's the doctor's responsibility, because in the end, the doctor is going to sign off and everything. But yes, when the robot becomes more sentient, so to speak, there is definitely going to be some level of regulation. I'm just in the dark as you guys are, as anyone's guess at the moment. But what usually is going to happen is that something will go wrong, and the government's going to step in, and they're going to create some sort of regulation around it, and they'll probably decide case by case about, or industry by industry about who takes the blame. That's as far as I can think.
If this doesn't convince you to live healthier, nothing will, okay? I know there's a robotic startup, but I want to ask these gentlemen here, because we have the chance. Robotics is a capital-intensive business. Like, how do you start the conversation with the potential customer? Because you got to get customer in order to get a reputation and to minimize your burn. So how do you guys talk to the customer, and what are customers really thinking about when they think about robotic for the first time?
I would actually focus on the solution. To me, is the problem we're trying to solve. I think, like I mentioned just now, robotics to us is a nice, sexy word, but it's really about giving a better solution for the doctors to use. So in our case, it's just a quicker, faster, safer way to remove cancer or gastrointestinal cancers from the patient. There is always going to be the cost element. They're always going to ask you, no matter how much you try to hide it, they're going to say, okay, how much this is really going to cost me? So you're going to have to work out your numbers. For us, if you do major surgery, let's say in Europe, it's going to be anywhere between 10 to 15,000 euros. If you use our system, yes, there's a capital equipment cost, but per procedure-wise, you're still talking about something under 5,000 euros. So when you work out those numbers, it does make sense. Now I know that a lot of the negative examples would be, yes, they will say maybe a robotic system costs twice as much, but it's better. And it can be a challenge. I've seen other companies try that route before, but I think end of the day, if you do prove that you can bring clinical benefit, again, from the medical side, you bring clinical benefit to the patients and the doctors, there's always a case to be made.
Tristan?
Yeah, look, I think that's well put. Ultimately, I never start a conversation with, hey, this is going to cost you $1 million. It's always, as I mentioned before, we look for really challenging problem statements that exist in industries around the world that are dangerous, laborious, that take a long time, that are ready for disruption. And when we start with that mindset, we're actually able to go out and find a problem that's expensive. So I mentioned before the gas opportunity, right? Like that's $30 billion a year. If I come in and ask them for $5 million for a solution that can detect that, then it's a no-brainer, right? So, I mean, for us, we very much focus on identifying real deep problem statements that we can then use our technology stacks to meet and improve on. And as I said, the compass for us is always, can we make this safer? Is this scalable? Is it cost effective, and can we deliver a better result? And if we can do those things, then there's usually very little conversation around price.
For me, because what Colin mentioned is totally correct in the medical field, because it's always going to be a cost-benefit analysis. So whenever we approach a hospital management, we approach the surgeons, usually we don't talk about how much does this cost in the first place. It's always going to be what your technology is, whether is it novel, whether is it helpful for them, what is the clinical objective, what is the clinical value they're going to bring across. It's going to be time-saving, it's going to treat my patient better. So only when that is being covered, then we come down to the cost, whether how much disruption are we putting into the process. Is it going to add additional cost? Not just on the capex, but in terms of the entire process, it's going to be longer. So in terms of development work, we have always trying to minimize any disruption or any added time to the current procedures, and as well as additional cost that we're going to impact into the system. But as I mentioned, cost has to be more affordable. Definitely that's the idea that we are heading towards. And for hospital, it's always what is the clinical benefit that this system is going to bring. If you can justify that, I always think that the hospital management is definitely willing to pay that little bit more to acquire a new system to treat the patient. Because ultimately, when you have the best equipment in the world, patients are definitely willing to pay a little bit more, and the hospital definitely has more money to, pay for the equipment that they're buying.
So what I'm hearing is you guys, to get the first couple customers, is you quantify the value you're bringing, not the cost of the product. But so for the robotic startup, don't tell them how much it costs. Focus on how much value you create. For NDR is training, it's less injury, it's precision. With what's H3 dynamic, it's about performing a job more frequently, cheaply, safely. That one injury or one death basically probably covered the entire project, a human injury or death. With Endomaster, it's about less trauma, faster recovery. When you quantify the value, only then what the cost of your saving makes sense. So I think that's really important for robotic startup. Go after the solution. Don't fall in love with your robot. That's a sex robot talk later. So serve the customer. So now we have a one or two questions that I think that's interesting. Do you think if you're going to invest in the company, do you invest in the hardware or the robotics? And where do you find those talents if you choose one or the other?
What was the question again?
Yeah, do you invest more in the hardware or the software driving the hardware? I think they're trying to find out if a robotic company should be a software company first or a hardware company first. And if you have $1 million to spend in your company, you put it on software or hardware at this point?
That's a difficult question.
Personally, right now, because we are AI driven, so software is the key to what we are developing. Hardware, basically, if I were to share hardware, it doesn't really matter. It has to be precise and good, definitely. But with AI, with software development, it's supposed to be able to pair or supposed to couple with different kind of device in order to use. So today, surgeons or hospitals or even consumers, you won't be looking at, even though the hardware is what you see, but it's really how well the entire system is going to perform. Because eventually what the customer is going to fall in love is not how nice it's going to look, not the hardware portion, but literally how well the entire surgery performs. And most of it, at this stage of time, it really entails back to the software portion. So software will be the largest proportion of what my company will be developing.
Sure. I mean, for us, I guess we focus more on the software piece, I suppose, but ultimately it's one of those questions, right? Do you take the hands or the brain? Either one on their own is not particularly useful, but I would make sure that you're invested in both, frankly, because one without the other isn't a particularly useful device.
Got it.
Yeah, to me, it's hard to choose one or the other. To me, it's whatever it takes to give a good product to the customer. It really depends on the situation, right? I may not know what you guys are working on, but for us, I guess we did invest in both. And I know I'm not giving a good answer between software and hardware, but it's whatever it takes to get a good product. I mean, that's how we did it.
Thank you. I think that's all the time we're at. Okay, that's all the time we have. Please feel free to come up. Ask for an autograph. It's worth nothing. I want to thank Alan, NDR Medical, for sharing his insight. Tristan from H Dynamic. So if they ever merge, run, because it's going to be scary. I want to thank Colin from Endomaster. They will, both of their medical company will be my service provider one day. So I want to make sure I know the CEO in case I have to complain. Thank you very much. Good luck. And I want to thank my panelists.
Thank you, Matt.